Hi, Keith. Mike.
Hello.
Hello.
Hey.
Hi, Dan.
Anybody going to KubeCon next week?
Not me.
Be there, cube train and all. So exciting.
Sal
Exactly.
and I will be there.
Where is it?
It's in Paris. It's the Kubernetes conference. And just to get started, before we get started, Thomas, the conceptual message wrapper, does that continue a previous discussion, or are you going to have like a little bit of we are here in the geography of acronyms from IETF?
Sorry, this is continuing what? A previous conversation?
So one of the topics today looked like it was you were on for conceptual message wrapper. See that right? Okay. I just was trying to remember if we're jumping into this from the beginning or this continues from.
This is just the starting anew. We were discussing previously something around composite attesters, and this somewhat links into that discussion, but it's completely new.
Okay, good. And I will have to quietly drop about halfway through the meeting. So.
Would wait a minute and see if someone else joins.
Hey, Thomas.
Hello.
Wouldn't the IETF, the IETF EAP collection type thing also play into the composite attesters discussion?
Absolutely, but CMW has now a collection type which supersedes the EAP collection. So we discussed with Simon about this and made sure that CMW was binary compatible with the EAP collection, and therefore we could drop that.
Okay, so it subsumes it. If we just think about this, we don't have to think about the other one anymore. With Simon's blessing.
Yes.
Maybe.
No, absolutely.
All right.
Long discussion.
Thanks for clarifying that. All right, I look forward to what you're going to share with us today.
Right. So please fill in the presence on the Google document that I linked in the chat. And yes, we have two topics. One is this CMW thing that I will take, and the other one is from Usama, Action for Chairs, issue number 13. Usama is here? No, he isn't. So I'm not sure. Maybe we want to postpone. What is 13 is okay. It's KBS, formal verification of KBS, on which we are supposed to take a vote, I suppose. Except I am one of the proponents, so I must recuse from any vote here. But obviously,
Yeah,
conflict of interest. But yeah.
I'm trying to remember. Was he looking for just building on the existing formal methods project, or he was suggesting creating something entirely different?
This was a lot of my line of questions last week. I think he was approaching it somewhat different, but was going to build it on top of the other. So I think it dovetails nicely together, and I'm supportive.
It does, except Cocoa has support also for AMD, SCV, SNP, which isn't covered by the previous project. So somehow we need to understand how and if artifacts from the other group can be reused in this context. But for sure, TDX and CCA can be taken as is and composed with the higher layers.
Okay, well, maybe if people can just drop those thoughts into the GitHub issue, and then Usama will know that there's some feedback there.
Okay. So action is to, let me jot this down. Hey, why can't I edit this? Well, I can't edit the Google document, so, but if someone can fill in the notes for me, that would be highly appreciated. But yeah, so I can start with CMW then. And I see Greg has a question on the chat. What happened to Jonah's discussion on attestation evidence collection standard package effort? I think she wasn't ready with that. She had some material, but not enough. So
yeah,
probably...
the scope of the conversation ended up being different than she had originally thought, and wanted to follow up some more before having the discussion in earnest here.
Okay.
All right, cool. So is that something that may happen in the future, or it's just on hold indefinitely? It was certainly interesting.
I think yes to both of the above. I think it is should happen hopefully in the future, but for now indefinitely postponed.
Okay, cool. Thanks, Keith.
I'll try to share my screen and see what happens.
I was just talking to her about this yesterday. She's still looking into it. So.
And hopefully the CMW thing will provide some sort of building block for that as well. So let's go. Can you see something?
Yeah, we can see it.
Yep.
Okay. So yeah, so conceptual message wrappers. So the work started here in the attestation SIG, and where we wanted to harmonize on the different formats for RATLS. And so Ned, myself, Hannes, and Henk, went away and tried to design something that would fit the requirements for that. But then sort of the thing exploded a bit and covered more ground that we anticipated initially, and that's good, I think. Yeah, so the idea is that you have to deal with a zoo of format, of pre-existing formats, right? Especially on the evidence side, you have TPMs, EATs, you have binary proprietary attestation formats of various sorts. But also on the ref value and endorsement side, you have different things like core suites, core rims. You also have TCG rims and other stuff. But in the RAS architecture, the three parties, right, that are that exchange evidence and that exchange conceptual messages are sometimes it should be sometimes ignorant about what the kind of thing they're transporting, because they are just relaying data from one actor to the other. For example, relying parties in background check, what they do, they just move evidence from the attested to the verified, but they don't care about that because they don't consume evidence, they consume attestation results. And symmetrically, attester in passport modes, they just take attestation results and move them between verifiers and relying parties without actually consuming the attestation results themselves. So having to know what the attestation result format is. So for these situations, we have made this wrapper with small wrapper that can transport any attestation message with any hosting protocol, right? At any level of the stack from layer 3 and even below. If you're using, for example, TLS, EAP, you might be dealing with data link protocols up to REST APIs, right? And through all the spectrum of application protocols. And the design choice. So this is the goal, and the design choices, the core design choices that we made was to have a simple container, so take the shim layer and make it as simple as possible, so that the thing could be transported with the minimal amount of metadata that is needed to, for example, for dispatching this, right? For taking routing decisions. The second design choice was to give them both JSON and CBOR representations so that they could be embedded within existing CBOR and JSON-based protocols, and that the typing metadata would be based on media types, RFC 6838. And why media types? Because they have a relatively cheap registration process that is already established by IANA and is working. If you look at the number of media types that are already registered, is humongous. So it exists, it's been successful, and it's used all over the place. Another major point, major selling point was the fact that alongside the standard sub-tree, so where you have to have you have to go through a standard organization like the ATF or TCG or whatever in order to and provide a spec that backs your registration. So it's a bit somewhat more complex machinery, bureaucratic machinery. You also have vendor and vanity subtrees. So if you look at the application /VND dot whatever, right? So for example, Google or Intel, whatever, or application PRS dot Thomas, you have much more relaxed registration policies there. And so you can, these are good spaces for experimenting and or making cheap registrations for your stuff. Alongside that, it allows, it also has compressed representations, which are made available through the co-op content formats. So co-op has made a compression for media types. That basically, if you have a media type, if you decide what the content coding is, which is typically identity, and then you set specifically which media type parameters you're going to use, you take this tuple here, and then you can ask IANA for a code point. So you have 2 bytes integer that represents that combination, right? Instead of having a very, very long string, you just have 2 bytes, and you can use it. And once you have that, you can automatically derive a CBOR tag. Basically, RFC 9277 allocates a portion of the CBOR tags registry to co-op content format, so that and defines a function called TN. And this function is bijective between these 2 ranges. So basically, if you have a content format, you have a CBOR tag, and vice versa. But you could also have CBOR tags natively, so you can go and register your CBOR tags through the standard method. But let's say if you have a media type registered in the media type registry, then you can request the content co-op content format, and from that you can automatically have a CBOR tag, which is pretty handy. And the 4th point is that these things are reusable, because once you have them, you could potentially use them in REST APIs or other contexts. So already, and they are possibly already available to you. For example, it defines their own media type. So if you decide that your attestation format is based on it, automatically you inherit a media type. So you don't have to register that. Okay, so which formats we define? We define 2 formats. One is the record format, which is available for both JSON and CBOR serializations, and is a 2-valued array with a 3rd optional value. Type and value are the first 2 things, so that are represented as either media type or content format, depending on whether you're serializing to JSON or CBOR. And the value is either a CBOR byte string or a base64 URL encoded without padding, if you're encoding as JSON. And then you have inde, which is a bitmap. Basically, you can signal which conceptual messages you are hiding inside this bag. So, for example, if you are using a quorum that is transporting both endorsement and ref values, then you can raise the two bits in the bitmap. The second serialization is the tag, which is available only in CBOR. And basically, the tag is the type, and the value is the thing that is embedded as a CBOR byte string. Very simple, but is a little bit less expressive than the other, because the other has the optional indicator, which you don't have in the tag. So let's see some examples. JSON record. You see the 2 elements, the record, the 2 elements. First one is the media type in the vendor space, subtree space. And the second element is the base64 URL encoded, URL safe without padding. This is the same exact, but with a CBOR serialization, where you have, it's the same, but it's binary. So you have the array 8, and with 2 elements, 82, and then the unsigned 30,001, which is the co-op content format corresponding to the application VND example, RAT's conceptual message media type. Okay, and then you have the serialization of the same basic value, which is wrapped in a byte string. So less overhead, much more compact, but it really depends on how big is the value that you're transporting, because the overhead becomes thinner and thinner if that increases a lot. And the CBOR tag here is basically the equivalent. So the tag that you see there is the one that is obtained through the TN transform from the co-op content format. So you'll see media type, content format, and now the CBOR tag, which are exactly the same thing semantically. And then the realization of the value as a byte string, wrapped byte string. So I think they are basically the same 1, 2, 3, 4, 5 byte overhead, 1, 2, 3, 4, 5, 6 byte overhead. So 1 byte difference between the CBOR tag and the CBOR array is just nothing. Alongside the base CMW, you have these collections that, as I was mentioning before, are based on the Simon design for the id collection container, which is in fact binary compatible with that for reasons. And these collections allow basically taking multiple different CMWs and stashing them together into a bag where each of the CMWs is named as a unique name. So you look here, this is the conceptual representation of this. So you have an optional collection identifier in form of an URI or an OID that allow you to type the whole blob in a unique way, in an ambiguous way if you wanted to. And then you have one or more key val pairs, right? A label, which can be, the name or a code point, depending on what you need or in your needs. And then on the right-hand side, you have either a CMW native in its native form or a so-called tunnel, which is a CMW that is somewhat rewrapped to go through a different serialization. So basically, the idea is that if you have a composite attester, right? So a top-level thing that has multiple sub-attesters, and each of the sub-attester is producing evidence in the same, is producing CMWs in the same format. So is say all CBOR or all JSON, then you can take them natively and stash them in the collection, right? But if one or more of them are not homogeneous with the rest, then you need to take that output and make it so that it can be serialized in the format that the top level collection is. And therefore you need a tunnel type. So examples, this one is a composite attester with 2 sub-attester, A and B, each having their own CMW, right? So in the array form. And then this is the tunneled one, where the second subattester is producing evidence in CBOR format, and therefore, in order to be collected in a JSON payload, it needs to be tunneled. So there's this special pseudo media type, CMW C2J tunnel or CMW J2C tunnel, which starts with the pound and starts with the pound for a reason, because the pound is not a valid char in the ABNF production for media types, and therefore it can't be a valid media type, right? So this is a sort of magic number or whatever you want to call it. And then you have the base 64 encoded the whole CMW in its native format that is base 64 encoded. So if you take that value here and decode it and pass it through CBOR to DIAG to get some more human readable stuff, you will see that the content is exactly the one that was here at tester B. Okay. By the way, if you have any question, just tell me and I will stop and answer. Now, collections are interesting because, of course, if you're trying to model a composite attester, you want to make sure. So this is becoming evidence, right? Because a composite attester produces evidence, and you don't want evidence to be subverted, and therefore you need to have some sort of sealing of the collection, right? So so that no one, a non-path attacker cannot change the thing without the receiver knowing that something wrong had happened. So to seal the collection, you have 2 options. One is external sealing that you can obtain in various ways. For example, if you want to wrap it in a CMW or a JWT, for example, if you want to wrap the whole thing into a EAT, we provide a CMW claim you can use in the EAT claim set that has as a value the collection or CMW, because they are the same thing, right? From a grammar perspective, a CMW and a collection are just the same. So the CMW thing can wrap an entire collection like that, can carry an entire collection of data, and then you add your other metadata, right? So issuer, expiry, and the profiling case. So this sort of models an EAT token.
Hey, Thomas?
Yes.
Can I
Yes,
ask
Greg?
a question in line? Is that okay?
Of course, yes, please.
So I'm thinking about this example in the context of being produced by a verifier, like Verizon or ITA or what have you, and thinking about consuming it from a relying party. And from a relying party's perspective, seems like certainly some of the formats, like the tunnel format's not going to be very usable. Has there been much thinking about how consistently usable the CMW format once you get to the innards here? Is that like a specific design goal or something that's not thought about, or has there been, I'm just thinking about this for the first time, and the thing that's in my head at the moment is that previous base 64 string you had up there. So I'm scratching my head saying, how's this going to be used by a relying party? What are some thoughts about that?
Yeah, so the thought is that I haven't thought about this. So the thing that I'm using this for at the moment is the composite attester thing. So this doesn't.
The attestation evidence versus the verification attestation results.
Yes, it's on the other.
Now, EAT itself is supposed to be for both, right?
Yeah, absolutely.
Okay.
Absolutely. Yeah. So for attestation results, I would say we need some thinking, deeper thinking. The
Okay.
original drive for this was the composite attester, though. So you're right that a composite attester maps naturally to some sort of composite attestation result, right? Where each of the individual bits are somewhat exploded and examined.
Yeah.
But
Is it? Look,
yes,
so
please.
is there more to it than I have an EAT, the token that contains a CMW claim that has the message type of attestation result where that bit is set, and then some whatever format?
It's the whatever format I'm drilling into, right? So if the relying party wants to basically consider GPU.0 and some particular attribute of it, which is currently in the ... Since the CMW is very flexible and could have embedded CBOR or base 64 string, just how easy is it for the relying party to actually essentially have policy, for example, Rego policy that says, essentially I'm looking for GPU 0, field
Yeah.
XYZ, has value of at least 3, right?
Right, but it could be something like application TPM, and then you're just getting whatever the TPM produces as output in TPM format, right?
Yeah, and part of the
that should be pretty clear, right?
No, it's clear, and I'm not saying the data isn't there. I'm saying how useful is it in the policy language of the relying party. Relying parties typically have, they have to consume this and make an authorization decision. And if you're basically saying, oh, look, we may throw base 64 at you, we may throw CBOR at you, we may throw JSON at you. I don't, I'm no expert, but I don't know of any policy language that kind of makes that easy, in all those,
I think you're touching on a bigger question, which is who gets to decide the format? Is it the root of trust? Is it the relying party? Is it the verifier? Somebody in between?
You may be right. I'm touching on it, but my intent is all my intent is scoped to a relying party. I'm creating a verification service. My customer is a relying party, and so I'm continuously asking myself, am I satisfying their needs? And I know their needs are basically to express some further authorization policy based on the data in the attestation results. And I specifically am only just trying to understand how applicable is CMW to a relying party scenario.
I think, Greg, the fact that these are wrappers is the key, right? So you need to unwrap this in order to use them. So I'm thinking that, you know, if your interest is the relying party and Rego on applying Rego policies on that, I think it is the easiest. The JOTs are the easiest. This one is,
so this
was a different, you know, kind of.
So if we go back to the IETF RATS architecture document, this is really thinking about the leg that goes from the attested environment to the verifier. Is that accurate?
Well, at least the motivating use case was that.
Okay.
Then there are other possible domains in which this can be applied fruitfully. Then, you know, the better.
My understanding was it could be applied for any conceptual message. That's why it's called conceptual message.
I understand that it can be applied. I'm asking the question, is it useful for a relying party without them, you know, using the tools at hand? And I think I have my answer. Thank you.
So just adding one bit more, Greg, this may be useful and maybe not be the only thing that you need, right? So if you need, for example, to convey raw evidence to your relying party for whatever reasons, right? Alongside exploded claim sets where they can apply policies. So this claim here would be a very good way, right? Because all stuff that I got from CPU 0, here you are.
I absolutely don't agree that there's possibilities that this could be used and that there are scenarios where it would be very useful. And I think from my experience and in terms of the customers I deal with, and from what I've heard Mark Novak talking about there's a whole lot of relying parties. The value of a verifier is to simplify things. So they're not really, you know, except perhaps for an audit scenario, they're not really looking for the rich, you know, raw attestation evidence. They have a business problem like, is this, you know, a trusted, secure environment based on my company's policy kind of thing. So they're just, you know, they're not, they want to, you know, they're dealing with some language like Rego or something to express that.
I mean, for audit and, you know, logging this stuff is great because you can stash it as a file, right? So all the metadata associated with that, and you can restore the exact content and context completely. But yeah,
Cool.
I will move on. Thank you for the question.
If we can get consistent attestation evidence, you know, that's a huge.
It's impossible.
Milestone in and of itself.
We throw the sponge here and say, okay.
Yeah. Thank you.
Okay. So this was one, right? So you use the CMW claim and wrap it in the protection that CWTs and JWTs give you. Or you could use, you know, other stuff like COSI sign 1, for example, and you take the whole collection and stash it in the payload, and then add the signature and whatever protected and unprotected metadata you want to stash there, and then send it over. Okay, the other option related to collection sealing is intra-collection locking. So basically, you are building somewhat a cryptographic mechanism that binds the bits together, right? The various CMWs that are part of the collection in some way, and we are experimenting with one such mechanism in the key attestation token based on it, where we have two tokens that are separate, one that attests the key and the other one that attests the platform, and they are carried as they both sign 1, wrapped individually, right, protected individually, and that contains some claim set. And the the locking here is realized by injecting a part of the key attestation token inside the platform attestation token via the it nonce. So basically, in the construction of the thing, you populate the it nonce of the platform attestation token with the hash of the key attestation key, the public key attestation key that is in the card. So the receiver can basically verify each sign one individually and then verify that the locking works based on the fact that if that relation holds, then there's been no subversion by a non-path attacker. Yeah, I hear sounds. No. Yeah, I think that's pretty much it. I think I forgot one slide though, which is the one that because these guys also have an OID that so that you can stash them inside X509 artifacts. So certs, CRLs, CSRs. There's an OID that we are registering for putting this stuff in an extension. So, for example, a third option here in the external integrity protection would be to stash the CMW or the CMW collection inside an X509 certificate or some other kind of protected thing, PKIX protected thing. So yeah, I've put a few links here. So when I put the slides on the repo, you can click. So the data tracker where the document is, the editor copy for the latest and greatest, the issue tracker if in case you have any question or issue, email the editors, and the RATS mailing list, which you are always encouraged to join for.
Thomas, may I ask, when you said that you're registering these OIDs and all the other bits and pieces, under what organization are you? Are you doing them as a CCC? Are you doing them as, what's the choice?
Is the ATF. We are going through the ATF process, and therefore these are all actions that go to IANA.
Cool. No, that's excellent. That's perfect. So I wanted to know where it's coming from. Okay, thank you.
Mm-hmm. So yeah, sorry, there's a missing slide. I don't know why and how I forgot about that, but yeah. But if you look at the editor copy or even the data tracker entry, you can see how that works in practice. And yeah, another bit of information, we have gone through the first working group last call last month, and in the RATS working group, we have addressed a lot of comments coming from participants in the group, and we're gonna have a presentation in Brisbane, basically, telling the group where we are at the moment, and that we think we are ready for a second working group last call, which could go possibly very, very quickly, and then ship the document out to the ISG for the final stages of review and publication.
Yes, one more question, Thomas.
Yeah, please, Greg.
I may have missed the details of the last slide, and it may answer my question, so forgive me if I'm asking something redundant.
Mm-hmm.
I'm pondering for the composite scenario, whether the CMW must be formed. Can it be formed kind of after the fact? So like if you have, it seems like it can, if there's no overall signature of the entire thing, right? You could have a intermediary component that receives and maybe that's just the way it has to work anyway, receives the attestation evidence in format 1 from, whatever your compute environment, and attestation evidence format number 2 from your GPU, and attestation evidence format number 3 from, I don't know, your network bus or something, and puts them all together into a CMW. Is that kind of the way we envision it working, or is that possible? Or it seems like it's possible.
I think this is Jonah's composite attester daemon idea, right? The fact that there's someone that is a system level agent that is able to do this, to discover the destination topology of the device and sort of go and collect all the pieces that are needed.
And maybe what I'm really trying to tease apart here is, does the party that produces the attestation evidence have to be aware of this format in order to play into this well? So basically, and I think the answer is no. So you could basically apply this to code that was written 5 years ago. Right. Okay.
Exactly.
Are there any super important scenarios where that's not possible and the component that produces the attestation evidence needs to be aware of this format?
No, I don't think so. It is that you get whatever you're given and then you wrap it. As long as the critical bit is associating a media type, associating a type to the whatever you've got. So in some way there has to be a negotiation, sort of or discovery or advertisement protocol internal to the thing that or convention that allows the lead attester to know what types these blobs, whatever blobs are. So that
and if some component were to basically wanted to attest that some subcomponents like this CPU and this GPU were somehow related, how would that work with CMW? Just with that?
Related, you need to well, related in what sense? Related in the
I guess is it envisioned that this is a go on.
Sorry, they have been computed in the same remote attestation session. Say, for example, you have they share the same challenge, or
let's just say there's some component that is going to sign for these two things are essentially associated with each other. So would they then model those two things as two things in a CMW with some additional part that I've yet to see that says, here's the thing, here's who I am, and I vouch for these two things being associated, like potentially a kind of pseudo third component that's the thing that's gluing the two together, and the payload there is essentially a signed signature saying I signed hash of 1 and hash of 2 into this thing? Or is it that there would be one thing in the CMW that was whatever the serialized format is that this component produced? So from the CMW perspective, does that bubble up into the kind of the CMW schema, or is it just, hey, it's just in the serialized form? Since it has the notion of a collection, does it, if the things are cryptographically
you need to bind the elements in the collection.
If you want to bind them, is that like a problem left to the serialized format, or is that something that's envisioned as being part of something CMW exposes?
No, CMW doesn't expose that, and therefore, there was collection sealing here. You have to have an external integrity protection or an internal integrity protection if the attester, if the composite attester is such that it can sustain that thing.
So unlike EAT, go on.
No, please.
So like compared to EAT with submods, you could have a submod, you could have two submods with signed attestation evidence for CPU, signed attestation evidence for GPU, and then the overall token, which has a signature that's like this thing that's binding the two.
That would be
what we found with the original collections things with this is that unfortunately submods tend to be the wrong way up. And your lead isn't necessarily at the right time or the right place. So you can do either have one part of the one entry in a CMW which looks up, you trust to look after the others, or as you say, you could have a meta one which refers to the others. It's the flexibility is the key.
Yeah, I reread the collection, at least the abstract and a few paragraphs the other day, and I finally caught the notion. This is like for when there's no obvious lead or to kind of make the overall statement. And I think what you're saying is as much as that applies, this applies, right? And if the two things, they could bind essentially by having the GPU, in my example, have a signed field by the GPU saying, this is the CPU I'm associated with, and vice versa. The CPU attestation evidence having something signed in that's saying, this is the GPU I'm associated with, and they just kind of point to each other, and it's just a flat collection.
Yep.
Yeah.
Kind of
And just because we've now abandoned the separate collection draft. It's now subsumed entirely into CWT, into CMW. Sorry.
Yeah. Thomas mentioned that earlier. Thank you.
Sorry, I arrived late. So,
Yeah. He stuck up for you.
Yay!
Thanks, Thomas. It's certainly enlightening for me to go through this with the new details.
Cool. Any other questions?
Thomas, there is a comment in the chat.
Ah, sorry, I'm not seeing it. That's not Dionna. It's not a nonce unless the key is used once. Yeah, but that is related to something I said.
Yeah, that's for the key attestation key slide. Here, yeah, where you say the nonce is the hash of the public key.
Right. Yeah, we are abusing the semantics there. So there is no, ideally one should have a user data claiming it, but there's no such thing at the moment. So we are abusing it nonce with that.
Okay, and then for what Greg was talking about, binding these several attestations together into a lead attestation, this collection type is only authoritative if the lead attester itself is trusted to do that collection. So this is where you would have your aggregate attestation collection daemon as part of your measured initial user space. So that's my understanding, but if we're not requiring that VMs use like the Verity FS for its init manifest, I'm not entirely sure what the plan is for binding multiple sub-attesters together so that this collection type is evident through some deeper protocol of threading through the expected combination of sub-attesters.
No, c'est bon, merci.
There's some noise. I couldn't get exactly all you said, Dionna.
So if we do not have that the evidence collector itself is trusted, but we do want to have binding between all sub-attesters, then it seems like we would need to come up with a different protocol for binding the sub-attesters together, such as abusing the nonce to have your nonce go into one that produces an overall measurement that you thread into the next and then continue following a deterministic order.
Yes. You do some ordered injection, of one into the other. And you're saying that in that case, the type is not meaningful because it's not the lead attester that decides the topology, but the topology is decided by the internal arrangement of the various sub-attesters. Is it correct? Is it what you were saying? Or
so if you have your attestation evidence collection daemons dynamically installed on a mutable disk, and you trust the signers of evidence because those are part of hardware, and you don't particularly care how those drivers are driven, so long as you can look at the outcome. Then you can't really trust the integrity of the combination of sub-attesters unless you have the full integrity threaded through. But even then, you need to say, like, I have an expected collection. Anyway.
Can I add something to that, which is that I think we're in danger here of combining a bunch of different trust contexts. So one is to say that I trust this party to make to do an attestation, verification, or measurement, which are different things to start with. The second is that I trust this party to be an attester about other things, which is a different thing, i.e., to decide what other things should be in this topology. And the third one is that I trust that this party is in a position to create an appropriate topology itself. And those are three different contexts, which, if we're not very, very careful, become part of the same evidence, and they should absolutely be separate contexts. Does that make sense?
It makes sense, yes. In fact, I envision different keys for stating these different concepts. Right? The keys
cool. Well,
each of the individual pieces, the key that takes responsibility over the collection of the integrity of the topology, basically, and they are different.
So that allows us to make decisions based on yes, do I trust the measurement, the validation, the chaining, and the topology of the chaining. And so there's possibly four different things. That's good. I'm very glad we're doing that. Let's make sure that is explicit in the work we're doing, please. That makes me very happy. Thank you.
I mean, this is just the data format. So I think people and specs that take this data format and use it for their own cases to fit their cases need to think about these dimensions. Maybe this is something that we could stash into the securities considerations of the draft, so that people
they absolutely do need to think about these things, but if we don't bring them out explicitly, people will not understand the differences because they're not well understood. So yes, we should put something in the draft about it, would be my strong view.
Mike,
cool.
Mike, can you stash these 4 points somewhere, maybe in here, issue tracker?
Where would I find that link, please?
Oh God.
If you could put it in the
chat.
Thank you. I will see if I can get into this.
Awesome. It should be public,
okay,
so.
I will add a new issue. Thank you.
Awesome.
Thank you.
Thank you. Right. We can wrap up then, maybe, I think. Sharing. Okay. So Usama, you are now on the call. We discussed previously, you weren't here. We took a look at your issue, and there was positive feedback, but we wanted to have some of the content captured on the issue about especially the relationship between this new work and the previous work that you completed. So there's an action on the chair to go and fill in the blanks there, ask the questions that will allow us to fill in the blanks. But apart from
Right.
that, yeah.
So what you are saying is basically the connection between the project that we did to the previous project, right?
Exactly. And in particular,
Okay.
I was raising this as one question mark that I have in my head, because it's clear to me how we can reuse CCA and TDX artifacts, but as far as the AMD, SCV, SNP work, that, if I understand correctly, has been done by a separate group, right?
Yes, yes, that's right.
Is it
So
possible to
it's
over
still under progress, to my understanding, but it would be completed soonish. So that would, as you know, like the academics, so the publication process takes some time, and I think it will be only after the publication that they will make it available publicly. But at least that's what they mentioned to me, that they will make it public eventually. So in that case, we can also integrate that AMD side into this. But then the protocol itself is agnostic to that, and I don't feel any problem. Like if it integrates with one of them, it would
Yes.
integrate also with others. So, and even the initial model that I plan to create would be very simplistic. That would only take some evidence, that would have two parts. Let's say the user-defined data and the other one, like the claims coming from somewhere else, the testing environment. So that would be the initial model, of course, and then we will integrate it with all the work we did there. So just to see that everything fits together, and by combining them together, there are no problem.
Okay, thank you.
Yeah, and sorry, I was here in Luxembourg. I had meeting with Peter Yan and so on, so I was a bit late in the meeting in the beginning. Sorry for missing that.
Problems. Okay. Next time is Tuesday 26th, and we have Stefan from IBM that will talk about attestation flows in IBM's S390. But we don't have a chair, so who would be happy to chair the meeting?
Volunteer on chat.
Hmm?
Jim is volunteered on chat.
Right. Okay, no problems. We will deal with it.
So, Thomas, Jim Beanie, who volunteered to chair the next call. Jim volunteered to chair the next call. Yeah.
Ah, sorry. Awesome, thanks, Jim. Okay, we can close it now, I think, unless anyone else anything to say. No? Then thank you very much.
Thanks again, Thomas.
Thank you, Thomas. Thank you. Bye.
Bye-bye.
Bye.
Thanks all. Cheers.
Cheers.